Hello guys, SPM exam is just around the corner. So let's do revision on additional maths for this chapter, which is quite challenging. We call as differentiation. Okay, so the key to success is actually the price of anything is the amount of life you exchange for it. So let's get started with the differentiation topic. So for differentiation, the basic is you must know the limit. So for limit, how to solve the limit? So can you see the question? Okay, I'll enlarge it. So find the limit when x approaches -2. Okay, when you have this type of function, the way to do is you have to factorize. Okay, substitute -2 into the function, you will get -2 square is 4 minus 4, and -2 plus 2, you will get 0/0, right? So in this case, you have to use factorization. So you will factorize the perfect square, which is, okay, 1 plus and 1 minus. Remember, a square minus b square is a plus b, a minus b, right? Okay, so when you have the x square minus 4, you have to write x square minus 2 square. So you write x plus 2, x minus 2, right? So then you have to simplify. So the way to do is you factorize and you simplify. Okay, so that is how you do the limit. So after you simplify, you can substitute the -2 into the function. So you substitute into x, so the value is just -4, right? So it's simple. Remember, you have to factorize. Step 1 is factorize, followed by you simplify. Okay, simplify means you cut here, cut up and down, right? Simplify. So there are 2 steps you need to follow. Okay, so we have solved the limit. Number 2, okay, when you see f prime, there is a prime there, it means differentiation, or it also means first derivative, right? So you're asking to find dy dx in short when x equal to 2. So we have the multiplication, right? Okay, let me erase. Okay, it should be prime here. So I'm going to use, do you think you want to use expansion? Some of you might want to use expansion, but I will use a UV. Okay, so okay, I will differentiate 2, bring down 5 minus 3x, remember? Okay, then differentiate the inside the bracket. Okay, then plus 5 minus 3x square, and differentiate the x, you will get 1. Remember, the method to do is we call as DOOD. That means you differentiate, okay, and then you fix one, you don't differentiate, right? Okay, so it's actually rotating of the differentiation, right? Then you substitute the 2 inside. Okay, because the question is asking for the f prime 2, so this one become prime. So I will substitute 2, 5 minus 3 times 2 is 5 minus 6, so it's -1, right? Okay, and then you times with the -3, and you take 5 times 5 minus 6, and then you square, right? So let's simplify. You will get the answer, which is, okay, so this is 1, this one you get 1, negative 1 square you get 1, and this one is 2 times negative 1, so is negative 1 times negative 3, positive 3. 3 times 2 will be 6, right? 6 times 2 will be 12. 12 plus 1 will be 13, right? The answer is 13. Okay, so that is the answer. Or maybe you can do like this. Some of you might want to do like this. You can do like this if you want. You have to expand first x, and then 25, and then 2 times 5 will be 10. 30 x plus 9 x squared, right? Okay, this is still fx. Then you expand like this, and finally you find the first derivative, or we call it dy dx. You got 25 minus 60x plus 27x squared, right? Okay, the power reduced by 1, and you substitute the 2, you will have 25 minus 60 plus 27 times 4, right? So you will have the answer, which is, okay, let's press the calculator. You have 27 times with the 4, right? And then you plus 25, and you minus 60. (25x minus 30x squared). Okay, so you find the 25 60 times 2. Where's the 2? Okay, there is a careless mistake here. Okay, let's do it again. So f prime x is 25 times minus 60x plus 27x squared, and then we will substitute the 2 inside. So you get 25 minus 120 plus 4 times 27. 4 times 27, what you get? 4 times 27, you get 108. So that means 25 minus 120 minus 108. Okay, you know, so right, the same answer. So up to you to do, the answer will be the same. Let's proceed to question number 4. Okay, you have to find the dy dx. dy dx is 3 times 3 x squared, power reduced by 1, and then 4, right? So the answer is 9x squared minus 4, and then you have to interpret its meaning. So dy dx means what? It's actually gradient function, right? It's a gradient of a function for the curve. For the curve y equal to 3x cubed minus 4x. Alright, so that is the meaning of the dy dx. Find the gradient of the curve. Alright, a gradient of the curve is actually dy dx, you know. So when you see the word the gradient of the curve, you write dy dx. So you're going to find dy dx for this curve, and then when you find dy dx, you need the x value, but they actually don't want to tell you. They say the curve, the it here, this one refer to this curve. Cross the x-axis, across the y-axis. When cross the y-axis, it means the x must be 0. So, okay, so the y will become 5, right? So that means the point is 0, 5, right? Okay, so now you have to find the dy dx and substitute x0. Okay, so let's do expansion first. So y equal to x cubed minus 3x, right, plus 5. So we are going to find dy dx, which is 3x squared minus 3, right? And then because the x is 0, so we will substitute x equal to 0 into dy dx. So the dy dx equal to negative 3, alright. So there is a negative because at x equal to 0. So negative 3. Alright, for this one, find the dy dx when x equal to 1. Okay, this one I have teach you how to do, right? So dy dx is equal to, we will actually take this one and we differentiate this thing. Okay, v du dx minus this one, and then we dv dx will be 2x over the v square, which is x square plus 1 square, right? Okay, now you need to substitute. Actually, you don't have to simplify. You substitute the 1 into there, okay, to find the value. So let's substitute. So let's say we put the 1 square plus 1. Here 2 times 1 plus 1. Here will be 1 square. Here will be 1. So finally, our answer will be dy dx equal to 1 square plus 1 will be 2, right? 2 times 2. 2 times 1 plus 1 will be 3, right? And then 2 times 1 will be 2 over 1 plus 1, which is 2 square, which is 4, right? So finally, our dy dx is actually 4 minus 6 over 4, which is actually negative half. Right, this is the answer for the quotient law, right? Okay, now I would like to discuss number 7. Okay, let's see number 7. You're given the function. Let me erase this one. Okay, for this one you're given the y, and then you're given u, and then you're asking to find dy dx in terms of the x. So this one you have no choice. You have to use a change rule. So dy du is equal to the 6 bring to in front, 6 times 2 over 3 u5, the power reduced by 1. So dy du is actually cut here, 4u5. Now we need to find the du dx, right? Okay, du dx is this thing. Can you see that? Okay, I'm going to do du dx is 3, right? So now you have to use a chain rule because the question asking for dy dx. Okay, dy dx. So very simple. I teach you this method. Dy dx is equal to, you write like this, and then here is dy and here is dx. So the other one, you look at the question, you should know it should be du, right? You have 3 unknown, so we just substitute dy du. We have 4u5, and du dx we have 3, right? So we have 12u5. Alright, so but what is the u then? The u is this thing, right? So we have, because the question say in terms of the x, so the question didn't ask for in terms of u. So we will write 12 times, okay, we will plug back 3x minus 5 to the power of 5, right? That is the power of 5, okay? So this is so-called chain rule. Okay, so now we have solved number 7. Now let's go to number with this question. So you are asking to find g double prime, okay, 1. So that means you have to differentiate twice, right? So first time you differentiate, okay, before you differentiate you express in power form, negative 3, right? So negative 3 Okay, so you have to times the 2, then 2x minus 1, then negative 4, then don't forget you have to differentiate inside the bracket. So g prime x, you will get negative 6 times 2, which is negative 12, 2x minus 1 to the power of negative 4. Now you need to differentiate one more time. Okay, second time of dy dx. So you will take negative 4, right? Negative 4 times negative 12 will be 48, right? 2x minus 1, and then minus 4 minus 1 minus 5 times the 2. Don't forget you have to differentiate inside the bracket. So g double prime x is 96 over 2x minus 1 to the power of 5. So if you substitute 1, you will get 2 times 1 minus 1. So you will get 96, right? Because it's 96 over 1 to the power of 5, which is 1. So 96 over 1 is actually 96. Now let's see question number 9. Diagram shows y equal to x squared minus 4x. Okay, so you're given the curve. This is the curve. So obviously you can find this point and this point, because if you let y equal to 0, x squared minus 4x equal to 0, that means the x-intercept will be at okay, let's solve. The x-intercept will be 0 and 4. Okay, so this is 0, this is 4, right? Alright, so now the question is asking find the coordinate of point B. Okay, where's the point B? The point B is here. Alright, so we can find the gradient for these 2 points, right? These 2 points. So let's find the gradient. M is 5 minus 0. Okay, y2 minus y1 over x2 minus x1, which is 1. So they are parallel. So M is 1. Okay, so let's see. The condition is they are parallel. Look at the question. Okay, point B is parallel to OA. So now we already got the gradient for the tangent. This is so-called tangent. Okay, this line is actually, what's the name for this line? Is tangent. What is tangent? The tangent actually means dy dx, right? So we are going to do dy dx for the curve. Where is the curve? So this is the curve. So dy dx is actually 2x minus 4, and the gradient is at the point B is 1. So hence we can solve the this one. 2x minus 4 equal to 1, 2x equal to 5. So hence we can solve the x is 5 over 2. Okay, the question is asking you to find the x and the y value. So in order to find the y value, you have to substitute into the curve, which is x squared, alright, minus 4 times 5 over 2. So the y coordinate will be 25 over 4 minus 5 over 2 times 2 times 2. So it's actually 25 over 4 minus, okay, so let's see, 25 over 4 minus, okay, so the curve is, okay, 2.5 minus 4 times 2.5, that is a square. Okay, 2.5 square. Okay, let's solve this one. Y is 25 over 4 minus 1, 2, 10. Okay, this is 10. Alright, minus 10. So is 25 over 4 minus 40, which is negative 15 over 4, right? So the point B is at 5/2 and negative 15/4. Okay, so if you write in decimal, it will be 2.5 and negative 3.75. Got it? Alright, so use the concept of the tangent to the curve is actually the gradient. Tangent at point B. Okay, this line, let me show you. This is called tangent. At this point is actually dy dx, and the gradient is the same with the line OA, so it's 1. So you can always let dy dx equal to gradient of the tangent. Okay, so now let's see another one. Number 10. Number 10, the gradient of the tangent to the curve is 14. Okay, so when we see gradient of the tangent to the curve, we'll do dy dx, right? So px cubed, let's expand first, then we do dy dx. Okay, 3px squared minus 8x, and we substitute x equal to 1, be careful. Negative 1 squared minus 8 times negative 1. So the answer is 3p plus 8, right? Is equal to 14. dy dx is gradient of the tangent. So that means 3p equal to 6, right? So we can solve the answer, and the answer is integer, right? 3p equal to 6. So p equal to 2, right? Okay, so this is quite simple. Okay, so for this one, p equal to 2, we have solved number 10. So now let's see question number 11. Okay, question number 11, you're given the point P lies on the curve. Okay, so equation of the normal is given. So when you have the curve, let's say you have a curve, and then you have the normal given. Okay, you have the equation of normal, so let's draw the normal. Normal will be like this. So where is the tangent? Because the tangent is actually dy dx. So now I'm going to show you how to draw the tangent. So the tangent, I use a purple line, so this is a tangent. So since they gave you the green line, this line, okay, this is the line which is actually normal. So that means your m is negative 1/4, right? And the tangent is actually this line. So the m is 4, right? Because they are perpendicular. Okay, m1, m2 is negative 1. So if negative 1/4, here the m will be positive 4, right? This is actually m2. Alright, so this is m1. So now m1 is dy dx, you know. Tangent is dy dx. Okay, let's do the dy dx, and we solve that the dy dx equal to 4. So dy dx is equal to, look at the curve, 2 times x minus 5, right? Or you can expand y equal to x squared minus 10x plus 25. You get 2x minus 10, the same. So dy dx is actually 2x minus 10. So here also you are getting 2x minus 10. So you equate to 4. Why you equate to 4? Because they are having the same gradient. Okay, so 2x equal to 14. So x equal to 7. So you're asking to find the point P, right? So you have to substitute into the curve to find your y. The curve. Okay, so this is the curve. So we'll substitute 7. So the y is 7 minus 5 squared. So y is 4. So that means the point P is at 7, 4. Got it? Understand? Okay, no problem. Okay, last question, right? All right, so for this question, let's see the normal to the curve, normal again. Okay, so let's roughly sketch out a quadratic function for this one. We have a normal is parallel to the straight line. Okay, we have a straight line to y equal to negative. When we see the line, we always want the gradient, right? Divided by 2 is 4. Okay, so the m is negative 1 over 2. That means the normal of the curve is parallel to the line, this line. I'm going to show you this line. Okay, I use the red color. I'm going to show you this line is actually somewhere here, which is negative 1 over 2x plus 4y. So the gradient is actually negative 1 over 2, right? Okay, so for this normal is negative 1 over 2, right? Then we actually want the tangent. Okay, so let me show you how to draw a tangent. Tangent and normal always perpendicular. And why we need a tangent? Because we can use a tangent to equate with the dy dx, right? Normal is not dy dx, okay? So dy dx is actually gradient of tangent. So from normal, you have to find the gradient of the tangent. Then you do your dy dx. And then you equate to the gradient here, the 2. So x is 1, right? Okay, so when you have the x equal to 1, that is means that, okay, we have the x equal to 1. You can get the point here. Okay, this point, x is 1. And how to find the y? You have to substitute into the curve. 1 plus 1, 1 and 2, right? Okay, so that is the point. 1 and 2. So now the question is asking you to form the equation of the normal at the point P. Okay, so normal, so the gradient of the normal must be using this one, and the point is 1, 2, right? Let's form the equation. M is actually negative 1 over 2, and the point P is 1, 2, right? So y minus 2 equal to negative 1 over 2 x minus 1. So y equal to negative half x plus 1 over 2 plus 2. So finally, the equation will be, okay, let me continue here, negative half x plus 5 over 2, right? 2.5. 5 over 2. So in short, you can write as times 2, 2y equal to negative x plus 5. Or you can write as x plus 2y equal to 5. Right? So, or you can use y equal to mx plus c if you want. Okay? So if I use y equal to mx plus c, I can find my c first. So I have the 1, 2, 2. Gradient is negative 1 over 2 times 1 plus c. So 2 plus 1 over 2 is c. C is 5 over 2. So hence the equation will be y equal to negative half x plus 5 over 2. Okay, so that's all my sharing for today. I shall continue for the next video sharing. Bye bye and have a nice day.